special cases when solving systems of equations. You want to either eliminate the p's or the r's, and as you can see, it's already ready to combine. If you combine these two, the p's will cancel, so we just jump right into combining. That cancels out, but this also cancels out, but this also cancels out. So you got to understand what you have left. You have the equal signs that come down, so that's your equal. There's nothing left on the left side, there's nothing left on the right side, so you have 0 equals 0. That's true. 0 is definitely equal to 0.
It's that 7 was 7.2.
Yeah, no, that's just the number 7 right there. So, so that's 0 equals 0. 0 is always equal to 0. So what does that really mean? That means IMS, and we probably shouldn't abbreviate because I don't think other math teachers do. That's infinitely many solutions, right? Infinitely many solutions. Now, visually, what would that look like? It's the same exact equation, same exact line. They just land perfectly on top of each other. Okay? So if I ask you to classify, what kind of system would this original system be classified as? Consistent, bless you, consistent, dependent. I can't spell. Dependent. Consistent, dependent. So that's a classification of that guy. Why is this happening? Okay, guys, copy this one down. Copy this one down and try to solve it. So on this guy, let's decide. Do you guys want to cancel out the u or the x's? U's. Okay. What would I have to do in order for something to cancel out with something else? They have to be the exact opposite values. So we have a 2u up here. What do I need down here? A negative 2u. So what I want to do is I want to modify the whole bottom equation by multiplying it by negative 2. And this is the correct work that you should be showing. So the top equation I'm not even going to mess with. I'm just going to rewrite it right here to the side. There it is, the same exact equation. Now the bottom equation, I am going to distribute that negative 2 into all three terms. So the negative 2 times u gave us negative 2u. Negative 2 times positive 2x gave us a negative 4x. Negative 2 times positive 3 is negative 6. And as you can see, when you combine the lines here, your u's canceled the way we wanted them to, but the x's also canceled. Does the negative 6 and the negative 6 cancel? No, you end up with a negative 12. So you really have nothing equals negative 12. Which that is no. As in no solution. Or you could do this symbol right there. You got it? Now, we are going to have this worksheet today for homework. And if we start looking through this worksheet that you're soon to get in a couple of minutes, you'll see that they're very simple systems to solve. Like this guy, what would you cancel, x's or y's? Y's, because this one's already ready to cancel. The negative y and the positive y, when you combine them, they'll disappear. You could cancel out x's, but you have to modify an equation, right? So some of them are really easy. Some of them are just ready to cancel out. Some of them, like on number 6, would you cancel out x's or y's? The truth is, it doesn't really matter. It's really easy, both. I'd go with the x's because 2 is smaller than 3, I guess. But it's really just as easy if you decided to cancel out y's. But the bottom line is you're going to have to modify at least one of these equations. So if you want to cancel out x's, you're going to have to multiply this whole top equation by what?
2.
Negative 2. To get this to be a negative 2x, that'll cancel with the positive 2x. Now let's say somebody else decides to cancel out y's. What would he have to multiply the bottom one by? Positive 3, right? So still, it's only a one equation modification. Now let's go to one that actually requires both. And I looked I'm looking through this whole thing, and none of these are all ready to cancel, or just one. This is the only one right here, guys. Might as well copy this one down. We're going to have to require a modification of both equations on this one. Go ahead and copy it down. So there's many roads to the same place. You could decide to cancel out R's or T's. They're both equally as easy, I guess, or challenging if you want to look at it that way. So I want to cancel out R's, and the only way that this R up here will cancel out with this R down here is if they're exact opposite values. So I need to change this 3R to become what? 6R. Now how am I going to do that? I'm going to multiply the whole top equation by a positive 2. Now if this does change, it will change to a positive 6R. What do I need down here? A negative 6R. So what am I going to multiply the whole bottom equation by? Let me change colors. A negative 3. That way I could get a negative 6R on the bottom. So this is showing your work. You put the number that you're going to multiply the entire equation by, and you put it in parentheses. And then I would just show my work, or rewrite the equation on the side. 2 times 3 is 6, and that's with the R. Then you have 2 times negative 2, that's minus 4 with the T. And then you have 2 times 1, which is 2. So there's my top equation after modifying it by multiplying it by 2. The bottom equation, by multiplying by negative 3, you're going to get the negative 6R. You're going to get the positive 9, because negative 3 times negative 3 is positive 9. And then the equal sign, and negative 3 times 9 is negative 27. So now, ladies and gentlemen, we are ready to combine the lines and eliminate a variable. Again, that's why they call it linear combinations. We are combining the lines, and it's also known as elimination method because we are eliminating a variable. In this case, the R's. So what do I have left? I have 5t equals negative 25, which means that if I divide by 5 and divide by 5, I get my answer t equals negative 5. A lot of you said that was the answer on that one. That's good. Let's plug it in to any equation you want to find the other variable. I'm going to plug it into the top one. So there's the top equation rewritten with the blank spot, because I'm going to plug in that negative 5 in place of the t. And when you multiply the negative 2 times negative 5, you get a positive 10. So that's 3R plus 10 equals 1. When you subtract 10 on both sides, you get 3R equals negative 9. And if you divide by 3 on your last step, you will get R equals negative 3. So yes, the correct answer is R equals negative 3 and T equals negative 5. If you choose to write it in a coordinate format, make sure you put it in alphabetical order. R comes first, so you put the negative 3 and then the negative 5. And that's as hard as it gets, where you have to actually modify both equations. Notice I had to modify the top, I had to modify the bottom. On the rest of these questions on this worksheet, they're either ready to cancel or you only have to modify one of them.